Hey, hello, and welcome to JP's Product Pick of the Week. This is me, JP, and this is our 10th episode of this show. I've been counting. Welcome. First of all, I want to say, please, if you haven't yet, and you're in the United States of America, today's election day, so please go out and vote. We're all depending on you. All of us are depending on each other, so let's do it. Let's go vote. I even made my little matrix sign here, and I got a sticker, so I voted. Please, if you haven't, go vote. It matters. So this is an exciting product. We have a fun product reveal. And like I always want to do, I want to tell you to go check out the product page. And there awaits a great discount. So here's the product page for today. It's product 4712. You can go to this URL. You can head to this QR code, just point your phone or your camera at it, and you will end up on the product page where you can watch the video inside of here. I'm excited to say this one has a 50% discount this week, and I will jump forward in time a little bit to show you. There is the discount, so that'll get you from $5.95 down to $2.98 on the product pick of the week. And before I go any further, why don't we go and grab the product, and then I can talk about it, even though I think you already know what it is. Yes, that's right. There it is. This is the LC709203 battery monitor or battery gauge. This is designed for checking the health or the voltage level and percentage of charge left, at least, of a LiPo battery, which I think a lot of us use these in our projects, and you don't generally have a great way of knowing how's the battery doing. So this is it. This is sort of the equivalent of that little thingy in the corner of your phone that tells you how much health you've got or how much battery life you've got left. What's the voltage in this case, which matters to us a lot, but also the percentage of health. And so before I go any further talking about it, why don't we get Ladyada herself to give us her view on this board in the new segment.
The LC709203. So many digits and letters, but this is a very nice little fuel gauge and battery monitor chip. I like this one because it doesn't do coulomb counting. It's simple, it's inexpensive, but it doesn't require a resistor in line. So it just looks at the voltage of the battery. You tell it how big the battery pack is in milliamp hours, and it will then be able to use the voltage that has like the kind of standard LiPo derating curve, like between voltage and percent full, and it will tell you both the voltage, so that's a basic analog digital conversion, and also the percent full. It can also do thermistor readings. There's a thermistor pin if you'd like. It can set an alert if the voltage goes above or below a certain level. You can just daisy chain it with any LiPo battery. So in this case, I just have a 1200 milliamp hour battery. It's plugged into the STEMMA QT board here, and then I daisy chained using that handy cable that I just showed you into a feather. So now I've got the feather running some example code. It's using this chip to read the voltage and percentage. And so now it's like, hey, you can see it's updating once a second. It's like you're at about 3.7 volts, which is 1/3 of the way. And then if I can grab, hold on, this cable, I can show you that, while you're charging, you can also monitor it. So now we're going to see this voltage slowly creep up as it gets charged. I'm not going to wait till it gets to 100% because it's going to take a while. It's really easy to use. It's just I2C, so it's a simple protocol. We've got both Arduino and Python code to use with it. So you can, what I like about it is there's a lot of times where people are like, hey, I have a microcontroller project or a Raspberry Pi or microcomputer project. I just want to monitor my battery, right? I don't want a full ADC. I don't want to do the math. I just want to know how good is my battery life right now. This chip does the job very affordably and very simply. So just daisy chain it with any single cell li-poly or lithium ion battery, run the code, and you can monitor your battery with ease.
Yeah, tune into our upcoming show, Ladyada Charges Things.
Yes.
And it's just basically this for
it's very zen.
6 or 7 hours at a time.
Well, maybe after we do a couple more things, we'll come back and we'll check in on this and see if it's charged up some more. But it did go up. It's now at 3.8 volts.
There we go.
Okay.
All right, and with that, Ladyada is...
New.
Yeah, all right. So what I'm going to do is set this up now, and we will take a look at how you plug this in. And I've got a couple of demos for you. One is very straightforward. We'll look at our battery levels in the serial monitor, and the other is more of a typical project where you'd really put things together and deploy this in real use. So I'm going to go to my overhead here, and what you'll see is if I take the lovely little LC7092038675309999 Luft balloons right here and use either of these two JST battery 2-pin connectors. It doesn't matter which one, which is nice. What we'll do is we'll plug in a LiPo battery here. I've got a 1200 milliamp hour LiPo battery. So plug that into one of these, and we don't need to plug the output anywhere if we're not using the battery, so I'll show you with and without using that load from the battery. So right now I've just got the battery plugged in, and now I will plug in a Stemma QT cable. This is one of our many Stemma QT boards, which are these super modular boards that are very nice and small. We actually have kind of a standardized size on a lot of these, and they all use this Stemma QT/SparkFun Quick connector to connect over I2C. So it makes it easy to plug into stuff. In this case, I've got a Feather M4 into a Feather doubler, and with this cool SparkFun Stemma QT Quick Feather wing that lets me plug into a few different devices. And now I'm going to go ahead and provide power to my Feather. So now it's going to use the battery to drive the chip and I2C to send the data over to the Feather. And what I'll do is I'll open up a session of Moo over here, and let's reconnect to our serial port. And there you'll see it starts spitting out. Let me move something out of the way for you there. It starts to let us know the battery level. So this is giving us the voltage. Currently the voltage is at 3.9, roughly 3.95 volts. And this is at 63.4% capacity. Now, like Ladyada said, if you keep this plugged in to the Feather, in this case, without charging it, we should see that level drop. So as you put a load on the battery, it's going to lower. But remember, I mentioned you can also send the load out from the battery to a port that you're driving, such as powering the Feather itself. But given, oh, let me restart this. I've just freaked out the board because it restarted. Given the fact that the Feather has a charging circuit, we're actually going to see this go up. So you can use this both in watching a battery go down or watch it go up if you're charging, which is really cool. Now, speaking of charging, I'm going to go ahead and disconnect this. Let me close my serial monitor there. And I'm going to switch over to a different demo for you. So we'll pull this over to the side. And what I've got here is a solar charger that I built. So here is, let me go full screen for you for a moment. So here is a big solar panel, and I think that focus looks pretty good, but I can fix that a little better for you. There we go. And sorry for the scratches on there, but what I have in here, there's a whole bunch of stuff packed into the box. So I have a big battery. I think it's a 2500 milliamp hour battery. I have the solar charging circuit. So the solar panel is charging the battery through that solar charging board there. And then I have our LC709203 battery monitor, as well as a little OLED display, and there's a little cutie pie in there that is running the display. So I wanted some way to drive the OLED and read that data off of our battery gauge. So right now, this is charging. Anytime there's enough light, it'll be charging. We might even see, yeah, there's not enough light in here right now, so it's not charging it right now. But we go in the sun, it'll charge this. And it'll provide power when I turn it on, the sort of second half of this circuit. You'll see it boots up our little OLED, and I can zoom in nice and close to that guy now for you. And now I can tell, okay, I'm putting out 4.1 volts, and I have 85% charge. So this is, I just built this half of the circuit into this yesterday, and I'm so happy to have it because I never was quite sure when I was charging using this solar panel how full my battery was, and I would go and use it. We kind of leave it outside as a charging station and plug things in when we're outside, phones or whatever. And this is actually using a power boost to provide that 5-volt USB. So I've got this little tail here, and that's what I can plug stuff into. But the beauty is now I know what my charge level is at. So it really kind of rounds out the project and completes it. Just so you can see it in action doing its charging thing or its powering thing, I'll just plug in a little Circuit Playground Express here that has a nice little blinky candle animation running on it. And so that's coming off of that battery. If I leave this plugged in long enough and there isn't any sun to charge this, we'll see this value go down. And like they said, it's maybe not the most exciting thing in the world to watch a show about charging, but maybe we don't need excitement right now. Maybe that's an idea. Maybe we need like a lo-fi hip-hop beat and something charging for several hours. That might be a fun show. So let's take a look. If you go back to our page here, this is the product page. And remember, you can get this 50% off, wild 50% off deal right now during the show. And we've actually tuned things a little bit. So if you put it in your cart and the show ends before you've hit buy because of lags and delays, we have a little bit of a buffer zone. So we have time now. So you shouldn't see anything disappear out of your cart, or you shouldn't see the price change. So buy it within, 10 minutes of the show, you'll definitely be safe, maybe a little longer. Here is the Learn Guide for the LC709203. So you can go and check this out to learn about using it with both Arduino and CircuitPython. This guide was actually recently updated as of, I think, this morning. We now have the CircuitPython docs on it, and that's what I'm using. You saw in my Moo session there, I was using CircuitPython to ask the battery for its health. And if you head down to the downloads section, you can see the data sheet, and I always like to do that. Here's the data sheet for this. Is the Smart Lib. I think it's probably lithium battery because this covers lithium polymer and lithium ion, I believe it is. Smart Lib gauge from On Semiconductor, and they'll give you all of the specifications and stats, environmental minimums and maximum for temperature and so on. One thing I'm not doing in my project here that I want to mention is that we do have the provision on the board to add a thermistor. So you can get a little thermistor, add that to the board, and then you can also report temperature. So you'd basically want to tape the thermistor to your battery or have it very close to it, and then this will report back temperature as well, which can be very useful in determining your battery life and health of the environment that you've put it in. Also, looking in the data sheet, you'll see some suggested uses. So the wireless handsets, smartphones and PDAs, MP3 players, digital cameras, portable game players, and USB-related devices, which kind of covers everything. That's a wide gamut of things. But basically anything with a lithium type of battery inside of it, you can use this chip that's on here to determine your battery health. And let's see. So yeah, those are the pages. We've also got, if you look back in my Moo session here, I'll just give you a brief rundown of how easy it is to use this. In my CircuitPython code here, I'm importing time so that we can pause, check every second or so is a good interval. I'm importing the board, so we have that library to give us definitions of pins, and the I2C library is the one we want to use within that. And then we're bringing in the actual LC709203 F library. Then we are instantiating that sensor on the I2C channel. The sensor pack size is something you don't have to use, but it helps it get a little more accurate guess of the percentage full by specifying what the capacity is of the battery. And in the guide, it tells you a little more about this, and I think it was in the library that I saw the hex codes for different battery sizes. I found it's actually pretty accurate without in the batteries I've been using and plugging into this, so that's maybe not necessary, strictly speaking. Then inside of my actually in setup, right before we start the main loop, we check the IC version. This will tell you the version of the chip that's on there in case that matters to you. But more importantly, once we get to the while true loop, you can see here we are printing out this one little statement, which is using some formatting tricks to basically place sensor.cell_voltage and sensor.cell_percent. And that's as easy as it is. Just asking for those two things will give you back that percentage and the voltage level that you're at, which will vary anywhere from 3.3 on the low end to, or rather 3.7 on the low end to 4.2 or so on the higher end. All right, so that is our product of the day. There it is. Let me give you a nicer picture of that. How about, there you go. There's two pictures of the same one. That's the product ID 4712. It's the LC709203 battery gauge. And I'm going to pull this out of this circuit now. Yank, yank. Got to be a little careful with that. There it is, the LC709203. And I will go ahead and put a little hang tag on there and hang this from my Stemma QT board of goodness. And that is my product pick of the week. So thank you all again for stopping by. If you want to go get that at the discounted price, head over to the main page, product ID 4712. You can get one there. I will also remind you, if the sign back there isn't, or my sticker, remind you to please go out and vote. And that is it. So thank you all so much for stopping by. And that has been another episode of JP's Product Pick of the Week, and I will see you next week. Bye-bye.